go to algebra 2 again.
Let's do counselor.
Alright, so we got 1, 2,
See what we
3.
think. We got patterns 1, 2, and 3 up here. We want to see if we can figure out how many squares will be in pattern number 43.
Let someone else answer it this time.
I mean, you can still figure it out for yourself. Just see if they're right. What do you think?
Clock you got. Oh my god.
It's math stuff. Yeah, you know it. It's all math stuff.
I don't know. Oh, that like word question.
Huh? Okay.
Just keep going.
I am. See what we notice. See what we see. When in doubt, start with how many squares are here. See how it's changing.
Oh, so it's N plus. I'm gonna get it calculated. How many people N plus 2? N plus 3. Right, it's something like that. N plus 3 equals 43 on this.
We want to be able to put the 43 in for an n.
43 plus.
For an x.
43 plus 3. Squared. I don't know.
I can hear somebody's music all the way up
Start
here.
dancing to it.
I'm about to.
Yes.
Almost.
Start playing some music.
Make sure that the expression you have would get these answers correct. So double check that your 1 and your 2 would be correct. Because I think it's just your plus that's off. How many squares are in this one?
I think like Joe, you can answer.
There's 7. 1, 2, 3, 4, 5, 6, 7. 7 squares here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here on this one. And on this one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Well, this one's nice. Just adding 3.
It's adding 3.
I think I have a question.
Say it again.
3n plus 4, would
Mhm.
that be a good question?
Yeah, 3n plus 4 would be a beautiful equation. Because we have our 3n, we know this is adding 3. So we know it's adding 3, adding 3. That tells us whatever's happening, we're going to have 3 times something. And you can set it up as 3n plus blank, and then we have to figure it out. As I said, we talked about one a couple of weeks ago where it was there 3n minus 1, that kind of vibe. Those things are kind of annoying. But if we want to do, with the pieces we have here, 3n plus something, if we look at the ones we have, I know that 3 for pattern 1 plus something is going to give us 7. 3 for pattern number 2 plus something should give us 10. What needs to go in that blank to work for both of them?
4.
4. 3 times 1 plus 4 gives me 7. 3 times 2, which is 6, plus 4 gives me 10. So 3 times whatever our pattern number is plus 4. You could also look at this as seeing that I have, one set of 3s. I have 1, 2 sets of 3s. I have 1, 2, 3 sets of 3s. And they're just kind of growing out in really weird places to get there. So you can do groups like that. You could realize that if you're looking at the pattern, I'm adding 1 here. I've got 1 set of 3s, 2 set of 3s, 1, 2, 3, because it's growing out on each of those legs. There's different ways you can kind of group them together, but it's all about trying to see how things are changing. When in doubt, start with how many squares we have and see how it's changing that way. There's lots of different ways to look at it. If you like to do it in the groups, if you like to think about it just as the numbers, if you want to look at the geometries of it and realize that it's just adding 1 on each of these 3 spikes. It's just kind of a weird looking one. Okay? Questions on this one? It's kind of a weird one. I know, I'm hysterical.
Yeah.
I'm so funny. I'm so funny. All right, we are going to be in our workbooks today. We got 1 page to do. Not even done. Oh, I'm going to funniest ever.
We have four.
I mean, all the stuff's written in there. Like, it's got the equations we're looking at. So, I mean, you can do it on a whiteboard, but like,
Just right.
I mean, I'm never gonna collect the workbooks to look at. Oh no, it is pulling mic. Okay. Whew. I was just like, oh no, I thought it wasn't pulling audio. It is. We're good. All right, so we're gonna be on page 83, and what we're given here is we're given two equations, and we're trying to decide if the equations are equivalent or will they have the same answer. Really, what we're looking to see is, do these things match? Did they do something that is an okay thing to get from one to the other? So we're trying to see if these are going to work, how these are going to work, and all that jazz. So you could go through these and you could get these all the way down to an answer and see if they work. Totally valid. But what we're really trying to do is we're trying to see how they went from this one. What did they do to get over to this one? What did they do, and are they allowed to do that?
Oh, they got rid of the X's.
They got rid of the X's. How did they do that?
By
Adding side.
Yeah, so they tried to get all of our X's to combine together. So what they did was they added 2x to this side, and they added 2x to this side. When they do that, 7 plus 7x equals 3. Is that an okay thing to do? Is that something we're allowed to do?
That's good.
Yeah. Because as long as I do the exact same thing to both sides of my equal sign, I can do just about anything I want. I can add things together. I can subtract things. I can add across my equal sign. I can subtract across my equal sign. Absolutely no problems. Whether it's got variables or not, I can do that. And then we can combine them together. This is absolutely valid. Yes. We can add. Because we can add to both sides of the equation. Both sides of an equal sign. I can absolutely do that. If we wanted to finish solving this, what would we do? If we wanted to get all the way down to an x equals, we would subtract 7 on both sides. So if we wanted to keep going and solve this, we would have to finish this out. Oop, there we go. We would get then our 7x equals, what is 3 minus 7? Negative 4. So we subtracted on both sides of the equal sign. That's absolutely okay too. If I want to finish this out the rest of the way, what do we need to do? By what? Seven. If I divide both sides by 7, this 7 and this 7 cancel out and become a 1. We get x equals a very unfriendly fraction. And that's okay. We can have unfriendly fractions. We're just going to leave it as negative 4/7. It's unpleasant. It'll be negative 0.5714285771, blah, 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 blah. We're going to leave it as a fraction and call it good. So we don't always have to take everything all the way down to an equals when we're doing these. Just trying to see if they match, if they're going to work. Did they do a valid operation? Yes, dear. Okay, if they've got your pass, you're good to go. So then I want you to look at the rest of these ones on this page. I want you guys to try this. See if we can figure out, did they do something okay? If they did, finish it out. If they didn't, tell me why.
I messed up.
Tell me why. So take a look at it.
I just
You weren't even looking at the equations. Where? That's the one we just did. I'm meaning looking at these specific ones. Not making them up. So look at a few of them. See what you think. Yeah.
Am I tripping?
How many classes you been going to in a week?
I'll say the class that gets the most traffic is definitely this one.
Oh, that's crazy.
To be fair, it's usually 6 periods because it's right after lunch.
Yeah, you know, some people would have to use the bathroom.
Yeah, some people just walk
It's that school food.
I didn't say you were wrong. Notice how there's none judgment on it.
No, we're talking about it.
No judgment on the bath situation. Very much one of those, I consider y'all to be darn near grown-ups, so I'm not in charge of your bathroom.
They say shoot or shoot.
Wow.
Yes, dear.
We go twist up the shoe. Hey man, shoot or shoot.
Yeah,
Yo, you blew him off, bro.
Something we love to do?
Blown all day.
Hey, bro, look how this my dick, bro.
We do not say that.
Don't say that.
Huh?
This is recording right now.
You know what that means, right? It was correct. Look up New Indiana.
I'm gonna say, I'm
No, that is not Indiana lingo.
Yes, it is, bro.
No.
I'm just gonna say, this is an open microphone right now.
Get rid of the three.
They got rid of the 3. Are they allowed to do that?
No.
No. This is not okay. We can't just remove the 3.
Stop.
Where's 3?
So now valid.
So, if we wanted to actually solve this, because they took out the 3 and be like, no, you can't do that. What could we actually do to solve this? There's 2 options that I could see.
Distribute.
One option is to absolutely distribute. I could take this and multiply that 3 into the x and the 3 into the -4 to get a 12. Absolutely valid. Did anyone do something other than distribute the 3 in?
Yeah.
Add 12 to 15.
What was our other thought? What was the other thought other than distributing?
You know, from the
From here, what would be another option to take instead of distributing?
Don't
Divide both sides by 3. That's what they were trying to do. They tried to divide both sides by 3, but they forgot the both sides part. Because I could absolutely breathe. Divide both sides by 3, and that would give me this very similar to what they had, my x minus 4, but they just forgot to make this be a 5. Either way, we should get down to the same answer.
For real?
For real, for real.
For real?
Oh, yeah.
For real, for real.
Stop. Stop.
Are you from the I?
No, don't answer them.
Are you from the I?
Please don't answer them.
I was going to say, if I don't know the reference, I do not commit either way.
You.
Do not answer that.
I'm not going to because I don't know what that means.
Indianapolis.
Yeah, Large Pass. I'm just going to go ahead and.
Let's set a world
Hey,
record
you
today.
should have a
Yeah,
permanent pass for people.
let's set a record right now. Pat.
So,
Can I go fill up my water?
what would we do on this one?
Add 12 to 15.
Add the 12.
Stop.
Divided by 3.
Yep, so we'd get our 27. We would then divide by 3. And we'd get exactly down to x equals 9. If we went the blue way, where I divided by 3 first, then we're adding 4. It's doing the exact same thing. It's just getting us down to our x equals 9 over here. So it genuinely does not matter which one we do first. There's a lot of times when we give you guys guidelines on what to do in what order, but it's not like law. It's just a, this is helpful.
But the before and after, they messed it up, so it would still be valid.
Yes, they're still wrong. X minus 4 does not equal 15. Doesn't happen. But when it comes to the actual solving stuff, if we're doing it, we have more than one option to get to the right answer. They just made a mistake because they tried to combine things together.
So it's not valid.
So they're wrong. We just solved the left-hand one because we could, because we're awesome like that.
Bro, let me do mine.
So this one is not a valid operation, but we can still solve the correct equation because we're awesome. All right,
You not really from the I.
look at the next one. like you talk like that middle school teacher on TikTok. It was like, bro, for real.
Yeah, she was mad spicy.
That guy.
Please don't.
6'7", 6'7", 6'7". Bro, be so for real.
6'7". Hindi skills.
Oh my god, be so for real, 6'7".
I'm bringing 6'7" water tomorrow. I'm not gonna be here tomorrow. I already college visit. Something like that.
I love that you're going on a college visit. It's fantastic. Plants.
I'm just stuff like that.
Got another one.
Is this your first visit?
No. No.
We can take the square root. No, we can't. We can't take the square root.
Mm.
You just
I
divide.
think it's an x squared equals 6x, x equals 6. This is divide by x.
Yeah.
That's what they did.
They can't do that.
Oh.
X squared. X times X.
Alright, skills.
X squared is x times x. That is absolutely valid. You could 100% write this as that.
You said don't take
I thought it was
Like you can absolutely rewrite it like that. We want to know if what they did here was okay.
Yes.
X times x. And then we can just subtract it.
I was like, from this one to this one. Is that okay?
Hell.
Nah.
Yes, I do.
See, I'm just not jacking that.
You're not jacking? You're not jacking the eye?
Well, y'all are rage bait too, man. We do not
You got no spicy, bro. Shit.
Are y'all not seniors?
Let's see. There's a lot of theories that seniors loop back around to be very similar to kindergartners,
This is the people that are going into our world in this beat.
especially in that conversations. I know.
I'm a senior. We are all seniors in here.
Hey.
This is the people that's going into our workforce.
You are not.
No, goddamn.
All right.
If he's a sophomore, I'm a freshman.
Lock it in.
I don't think you want this
Bring it
recorded no
back.
more. You might as well delete it.
Bring it back. Bring it in.
This one's going in the record books. Like, she's gonna show a class this 10 years ago. I mean, 10 years later.
I'm giving you my dude.
Stop.
Oh my gosh, guys. Y'all is so squirrely.
Alright, you right. Hey.
So is this okay?
Nah.
What did they do?
They
Divided
literally.
by X.
They divided by x. I was like, we can add and subtract and multiply and divide by a lot of things, but we try really, really hard not to divide by x's.
Really?
Why?
Because, like, divided by X is like.
Think about x squared, just in general, x squared. What does it look like if we were to graph it? Do you remember?
I wasn't here, so I can't answer.
Algebra 2. You spent like 2 months on it.
Oh, I wasn't here.
I would say the boxes, I was going to say that would be when we're trying to factor.
You would have played one of it.
If we think about x squared, remember these guys? Looks like this. How many solutions do they have? 2. Our solutions, our roots, our zeros, our x-intercepts, all those words all mean the same thing?
Those are still solutions, though.
They're still solutions. How many solutions does this have?
We're supposed to have one.
This just has 1. How many is this one going to have? Probably 2. This is a solution to what's over there, but it's not all of them, because when we have an x squared, we have to take this and factor it. We can't just divide by x's. It actually takes away one of our valid solutions. It's not okay. So we don't want to divide by x's because it can cause one of our real solutions to disappear. It eliminates something out. So we can multiply by x's, we can add, subtract x's, all that we want to. But we just don't want to divide by our letters. So, not okay. No. And I'm going to put it up here. We don't divide by the variable. It causes one of your valid solutions to disappear. And only if you're really lucky is the answer that you get still going to be an actual answer. So we can't divide by a variable. Or at least it's really strongly disrecommended. I'm going to say there's times when it can, but it's really, really, really not recommended. So, there's only one more on this page. Honestly. I know. I'm terrifyingly nice sometimes.
Yes, sir. Bro, this see.
So we want to see what they did,
Oh, they
and are they allowed to do that?
multiplied by the denominator?
They multiply by the denominator. Because they went, ew, fractions, gross.
They can do that.
Even if there's an x in it,
Oh,
Well, yeah, we can multiply x's.
Yes.
we can multiply by x's. So they multiplied
They multiply
both
Yeah, they multiply
sides
the denominator.
by the numerator and denominator.
Combine.
by the denominator. Numerator, where numbers go, it's the top. Denominators, they're the things that make it demonic, so it's, and denominators very much makes it sound like demon. So it's the number on the bottom is the one that makes it a fraction, the denominator. So if we don't remember it, it's kind of a little way to remember that it's the one on the bottom that makes it a fraction and scary.
I love you.
Stop it.
So we could finish this out. They did just fine. They multiplied both sides here. It's not going to be pleasant, but we could do it. What would we do in order to try and solve this?
Yeah.
So this is an okay thing to do. What would we do in order to finish this out? You can absolutely distribute. 1 equals our 10x minus 50.
We add the 50.
Add 50 to both sides. Beautiful. Let's say if we add 50, add 50. Yep. So we're going to have 51 equals 10x divided by 10.
What is that, 5.1?
Mm-hmm. Even without a calculator, we got a decimal answer on this one. You could get 5.1. You could put it in the calculator. You could put it as 51 tenths.
So this is valid.
It's totally valid. Absolutely a valid thing we can do. The only time we're going to run into problems with that is, what is the one thing in all of math we don't divide by? 0. So the only time we're going to run into a problem with it is if that little phrase, that guy in the denominator equals 0. We don't have that, so it's not a problem.
I can do this.
I was going to say, that's...
Patterns wonder way too hard.
Huh?
The patterns.
The patterns, part of the reason we practice the patterns so much is because they are such a weird way of thinking about it, but it's a thing that actually happens in real life because it's all about seeing how the math is affecting in the real world. And a lot of times, we don't hand people equations. It's just, what's happening to my farm field? What's happening with the animals? What's happening to the staircase? Whatever. Real life stuff. Or how do I put together this game to make the Plinko board and like Price is Right? There's a lot of those kind of patterns involved in where those pins are set. So a lot of those things are very tied together by those patterns. So the patterns and the equations, yes, we're a lot more familiar with the equations part, but the world exists in patterns a lot of times. So that's part of the reason we practice those patterns so much. So we're actually in a really good place this week because we are starting one of our card activities tomorrow. The one that I pick your partners, and we've already done the little pretest for it. My 7th period didn't get to it on the day that we did, so they have to do that today. So that's what I'll be using this time with my other class. So what you have is you have some time where you guys can start on the homework. A lot of this is very much based on what we did today. Dude, there are like 3 in the chapter. There is 1 for the week.
All right.
And it's question 2 from the chapter. The chapter started last week. So there was 1 last week, 1 this week, and I think there's 1 next week. Ta-da. And I'm giving you 15 minutes right now to do it.
Is it on campus?
Yep.
I gotta go.